Okay, good afternoon. My name is Paul Love. This is David Lake. We're here to talk about the Northcote house on the land of Wurundjeri people. Design of the project started in 2016. Took about 5 years to complete on site over the pandemic period. We are the clients. I'm the owner builder. We also have a registered builders on board to help with the build. So the project is located in Northcote, 4 kilometers north of the CBD. 6 at the rear of a shop unit where the land was used as a tandem car park. The area is well serviced by public transport, but it's only accessible by a laneway. Surrounding the site are large gathering hall-like spaces, churches, theatres, and large formal factory lofts, all of which inspires the volume of the house. Located 3 kilometers further north of the site is the Power to Make workshop, and this is the manufacturing side of our business. And it's co-located with the design studio. And here we operate robotic CNC machineries for architectural research. And for this project, we develop prototypes and manufacture some of the components. So the entire house is So the design responds to the narrow site conditions, 4.6 meters wide and 22 meters long. Concept is to elevate the ground so it creates a roof garden. The house looks to re-conceptualise a terrace typology to bring light deep into the interior. And we speculate on how the same typology can be used as infill to similar underutilized site in the area to create green fingers that can support the growing density of our cities. So the entire house is 82 square meters. We start on the first floor of the house as we enter from the laneway up the staircase to the large kitchen and dining hall. The north boundary wall blocks the warm prevailing wing, and the existing built form on the southeast allow paths for the cooler southeasterly wind to cross-ventilate the house. The timber stairs descends down into the snug, and the snug with a wood fire heater is the center of the house. We use a circle as a primary spatial device to create a snug and the 2 east and west bedroom, where the in-between spaces are antechambers and vestibules, which contains wardrobes, bathrooms, and utility spaces. So the rear of the house is a courtyard with a 3,000 litres water tank, herb garden, and a spiral staircase to take you up to the rooftop terrace. The terrace is 9 square meters using recycled products and provides for a provision for solar panels to the north. The rest of the roof is brown roof for ease of maintenance, which also contributes to the local ecology. Planting on the roof is irrigated by the water tank, and the added benefits that run off from the irrigation returns to the tank. So the section shows the 2 meters level differences across the site. The cantilever eave provides shades to the veranda, and the internal wall is a highly textured concrete surface that provides thermal mass, and the pleating textures disperse sound to reduce the flutter echo effect to the parallel boundary wall caused by the typology. So in the early stage of the project, we experiment with the concrete texture using the router bit to create pleat textures to increase the surface area of the wall. And the pattern is cut on a high U-value PIR foam board, which are later being upcycled as insulations for the roof. We managed to insert the PIR board in between the Perry formwork system on site, and we choose to use a modular reusable Perry system to eliminate construction waste and to deal with the very tight site conditions, as it also provides own scaffolding. So despite high embodied energy, concrete has sustainable advantage over the timber frame constructions due to longevities of the structures, and with the many of the architecture component designed for this assembly, the shell of the building can be repurposed in the future. So this is a photograph of the large hallway halfway through the build. It shows the day joint about 600 millimeters off the ground of the concrete pole. And in order for us to make sure that the pattern continues up into the next pole, we scan the entire site in order to adjust the manufacturing patterns to account for creeps and tolerance on site, so we can create a highly crafted surface, but as well as trying to reduce design waste. So thermal mass has allowed us to not have air conditioning installed in this house. Internal temperature has remained around 10 to 15 degrees cooler from the outside during peak summer, as we also utilize nighttime cooling. The house is detailed to achieve high air tightness. The reason test proof air tightness of 2.1 cubic meter per hour at 50 Pascal. Anything below 3 is considered excellent. Together with a heat exchanger, the interior air quality is also filtered and of high quality.
The roof is made from cross-laminated plywood panels in collaboration with TGA Engineering. The asymmetrical roof shape responds to overlooking from neighbouring windows and maximises daylight to the interior. The deep roof structure is designed to block out the harsh summer sun and diffuse winter light when the sun is at the highest point. Power to Make fabricates the roof structure within 4 kilometres of the site. Part of our design strategy is to tap in the local manufacturing capacity of the area. The stair geometry is bound by a circle of the lower floor and the elliptical opening of the upper floor. It consists of 237 layers of CNC milled FSC certified plywood. Threaded rods are used to clamp the entire structure, in effect post-compressing the layers to minimize the use of glue. The structure is designed for disassembly. The east and west facades are designed as giant trellis for planting to grow over the elevations, also designed for disassembly. We will take you through the house to finish our presentation. Starting at the laneway, the half-sunken elevation with stair leading to the veranda with the deep eaves to protect solar gain from the mid-morning sun. The hall-like dining room with the plywood laminated roof. The materials were chosen for their natural finishes. We have avoided using painted finishes anywhere in this house. The compact kitchen and dining island where the ceiling lowers to create an intimate space. All appliances are electric, there's no gas in the house. A view looking back at the east elevation, borrowing the greenery from neighbouring facade. The black column is the flue from a wood burner in the snug. By rising up through the void, it's able to heat up both floors. The veranda space here, you can see the brass inlay to the concrete day joint. 13 roof lights bring diffused light into the interior. A view looking down into the snug with the giant cushioned floor. The tops of the stair treads are lined with brass, which will tarnish and scratch over time. The layering of the stairs, the brass conduit conceals air duct for the heat exchanger. A view looking up from the snug to the roof beams and skylights. The east bedroom with the vaulted concrete soffit takes the load of the roof above. You can see the pattern aligned thanks to the digital feedback process of using point cloud scanning. There's a circular window in the northeastern corner of the room to pick up the morning sun. It's a mouth-blown glass piece by artist Ruth Allen. The glass distorts the light entering the room to give a soft glow. The morning ritual of using the ensuite benefits from this soft glow. It's a view from the rear courtyard towards the rest bedroom, showing the rain shelf and the outdoor shower below the circular stairs. The west elevation showing the trellis-like facade for planting. In coming years, the facade will be covered with greenery to shade the summer sun. We finish off with a view of the urban brown roof that contributes to and supports the local ecology. We grow sedum in these sausage-like planters. Now, this was taken about 4 months ago and it's now spreading over the entire roof. The intent of the roof is to help reduce the heat island effect, introducing greenery where little currently exists. Thank you.